pure reaction. Chemistry is all about chemical reactions. Things combining, changing, and forming. Remember, chemical changes are when the formula, the arrangement of the atoms change. We've got chemical reactions. So let's look at the type of reactions we have. First type of reaction that we have here is, let's look at these reactions here. Now, how are these two reactions different? How would you describe in words what happens to the reactions in each case? Think now. Enough time? Okay, the first one. First one looks like you've got something and it's breaking apart. Second one looks like you got something and it's coming together. Simple words, simple ways of describing it. They're similar, they've got some similar elements in it, but they're definitely different in terms of coming together, breaking apart. Now, let's look at how we could describe this in easy terms. How do atoms rearrange form new products? We're going to look at patterns that you looked at in class about chemical equations. Now, you may ask, well, why do we want to know about these patterns? What's the big deal? Well, if we have a submarine like this car here, car submarine is pretty cool, look it up. Now, submarines, in order for them to work properly, if you're inside of a submarine, you need to have the ability to breathe oxygen. You breathe oxygen in, you expel carbon dioxide out. If you have too much carbon dioxide and not enough oxygen, you die. Too much oxygen, not enough carbon dioxide, you die. So you need something that will take the carbon dioxide out of the air and put oxygen back into the air. That's at least the ideal goal. Now, one particular reaction is if you took carbon dioxide, gas that is breathed out in a submarine, or even in a space station. Okay, you've got to control the CO2 coming out. So to do that, one particular chemical you can use is sodium oxide. Sodium oxide is Na2O. Why is it Na2O? Because you've got a positive charge here and two negatives there, so you need two of these sodiums for it to be neutral. Now this is a solid material, and when these two combine together, it makes a compound known as sodium carbonate. And this is a solid compound, sodium carbonate. This compound is pretty unique because this compound also can be used for washing things. It's called washing soda. But the cool thing is this takes the CO2 out of the gas and removes it from being in the air. So there's less CO2 in the air. Now, less CO2 in the air is good, but you also want to make sure you have enough oxygen in the air. So a reaction you could do is you just take a sample of a solid chemical here, and this is potassium chlorate. Now, potassium chlorate will break apart into potassium chloride, two of these, solid, and 3 units of these gaseous molecules. So it produces the oxygen gas we need to breathe. Now, this reaction here is with the things coming together, and this is called a combination reaction. And this is when the things are breaking apart, so this is called a decomposition. So those are the names that go with these basic types of reactions. Combination, example of this here is CO2 plus NaOH, makes sodium bicarbonate. Decomposition, calcium carbonate here with calcium oxide and carbon dioxide. So this is producing carbon dioxide, this is absorbing carbon dioxide, so to speak. The next type of reaction is called a single exchange. Here's an example of a single exchange with chlorine and sodium bromide solid, chlorine gas. So this removes the chlorine gas and produces liquid bromine. And here's a double exchange with silver chloride and barium bromide, and you've got silver bromide produced and barium chloride produced at the end. The last type here is a combustion, which we will look at in more detail in our fire unit, but it is a fuel reacting with oxygen, producing CO2 and water. And these are usually the products of a combustion reaction. So these are the 5 types of reactions we need to know. Now, these 5 types here can be written in a simple form because there's lots of equations that fit these types. The first one, combination, A plus B makes AB, two things coming together. Second one, decomposition, A and B breaking apart, and usually this is into the elements. Not always, and that's the difficult thing about predicting what happens with a decomposition, but often it's into its elements. The next one is called a single exchange, and to remember this here, I just remember a little story. A long time ago there was a president of the United States, and he was married to his wife, and his name was Bill Clinton, and his wife's name was Hillary Clinton. And Bill and Hillary were married, and they were living in the White House, and along came Monica Lewinsky. And what happened, we don't really know, of course. Bill denied everything, and somehow Bill and Monica connected together in some way, and that left Hillary by herself to run for president. Now we know Hillary is now Secretary of State. That's an easy way of remembering the single exchange reaction. Now, could you plug in somebody else here? Absolutely. I mean, Jennifer Aniston, Brad Pitt, any celebrity almost, right? Anybody could be in here. That's called a single exchange reaction. Now, the next one is called a double exchange reaction. This one here, easy story to go along like with this. Sometimes I call this the double date reaction. There used to be TV shows, there probably still are on TV, that you have one couple and another couple. So here we've got Abe. Now Abe wanted to ask out this amazing girl that he looked up to, and her name was Xena Warrior Princess. She was quite strong and powerful, and so he asked to go out to dinner with her. But he was a little bit worried because she was a very strong woman and had a strong character, and so he wanted to have his friend come along with him. And so he asked his friend Ben if Ben would go along with him, and Ben said, I don't know. I guess I'll go with you, but I think I'll need to find someone to go with me. And so Ben thought, well, Yasmin is really nice. So Ben and Yasmin went out, and Abe and Xena went out. And during the dinner, one thing led to another. They were sitting there, and Abe thought, well, Yasmin kind of looks nice. Maybe I'll talk to her. And they started talking, and at the end of the night, it was Abe and Yasmin together talking, and Ben and Xena Warrior Princess together talking. This is an example of a double exchange, or double date, or double replacement reaction is what it sometimes is called. Pretty easy to remember. Last type of reaction is called a combustion reaction. This is when you have a fuel reacting with oxygen. Now this fuel can be something with carbons and hydrogens in it, called a hydrocarbon. It could have even carbons, hydrogens, and oxygens in it, or it could be a metal material, like a magnesium, for example. Now, most of the time when the fuels are hydrocarbons containing carbon and hydrogen, it forms two oxides, carbon dioxide and water, which is also called dihydrogen monoxide. And this reaction always reacts with oxygen. So we'll look at magnesium later and how that reacts, but normally you put your fuel in here, you write out the rest of the reactants, which is oxygen, products which are CO2 and water, then you balance the equation and you have a combustion reaction. So these are the 5 main types of reactions. Most of the chemistry we're going to look at fits into those 5 main reactions. Now, combination reaction, a way of showing this, it's easy to spot because there's only one compound on the product side. Decomp is when you've got one thing usually breaking up into 2, okay, one reactant. Single exchange, this is when a compound breaks apart, one part combines with the other reactant, either an atom or a group of atoms. Okay, so if you've got a nitrate ion, a carbonate ion, a hydroxide ion, usually they stay together as that group. So if this C was a hydroxide ion, that C would also be a hydroxide. This is a trick when you're balancing the equations. Keep them grouped together, this group of atoms. It usually works. Not always, but usually works. So this is when one displaces the other. Okay, Bill Clinton, Monica Lewinsky situation. Double replacement, double date, 2 reactants exchange parts. So in general, A and C exchange with each other is one way of looking at it, or you could look at it from B and D swapping places. Okay, this is just a generic way of showing they swap partners, so to speak. Now, the reason why they can't just combine with anything has to do with the charge on this. So A and B plus C and D, if it's an ionic compound, A is going to be positively charged, B is negative. C is positive, D is negative. There might be more than one negative. And if you look at this, A and D could connect because one's positive, one's negative. So what happens is they separate out, maybe into a solution. There are ions floating around, and then they connect together with something different and form a new compound. So this is why a double exchange reaction could take place, and B could combine with C. If A combined with C again, it's the same thing if A combined with B again, it's the same thing we started with. If A and C tried to get together, A is positively charged, C is positively charged, they would repel one another due to their electrostatic repulsion. So that's the reason why those positives wouldn't come together. And the same for the negatives. That's why they wouldn't come together. Now, the reactions here that we sorted through show that the toxins can react to the body in many ways, and these type of reactions happen in our body, as well as being useful for submarines, the space station. They have what are called scrubbers, which actually take the carbon dioxide out of the air and then add oxygen into the air almost simultaneously. And these reactions here, if you could couple them together, you could make a really good scrubber or machine to clean the air. Another thing that's used on submarines is they have a large amount of moisture that comes out of people's breath in the submarine. So they actually have to remove the moisture, so they use a dehumidifier to remove water from the submarine so that they can have breathable atmosphere. If the atmosphere is not breathable, submarine, no matter how many people you have in there, you're in trouble. In chemical reactions, they can be sorted into categories. There are 4 general types, as well as the combustion one, which is our 5th type. So let's look at this chemical equation. Predict what you think the products would be and make sure the equation is balanced. Here's your check-in number 1. Next one you're going to do, check-in number 2. This is a chemical reaction which describes a double exchange between chromium-3 nitrate and sodium chloride. So predict the products and then make sure the equation is balanced.